talk about multiplying exponents. Alright, so let's start out with an exponent that has the same base. Okay, so 2. 2 squared times 2 cubed, or 2 to the power of 3. Okay? Alright, so this is something that is a rule of exponents. When you times an exponent with the same base, and if you remember correctly, the base is the thing that's on bottom, the number on bottom. So here the base is the same, 2. When you times those together, it's going to be 2 to the power of 2 plus 3, which is 2 to the power of 5, okay? Alright. And therefore, say you had something like 2 to the power of 5 times 2 to the power of 4, that's going to equal 2 to the power of 9, okay? Now, if you were asked to evaluate this, meaning if you're asked to solve this and find out what 2 to the power of 9 equals, you could rewrite that as 2 times 2. If you don't have a calculator, you have to rewrite it as 2 times 2 times 2 times 2 times 2. That's what? 1, 2, 3, 4, 5, 6 times 2 times 2 times 2. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. Now what I would do if it was me is I probably would just break it down into something simpler. So I'd do, for example, 2 times 2 times 2, that equals 8. So let's draw a line in between that as 8. And then this would be 8 as well. And then this would be 8 as well. Well, I can do 8 times 8. That's easy. That's going to be 64. Okay, 8 times 8 is 64. But I don't know what 8 times 64 is. Now I could, if I wanted to, break it down to something easier, I could reverse this and make this 2 times 2 times 2, and then I could do 2 times 2 equals 64. I mean 2 times 64 equals something, and then times by 2 times by 2 times by 2. But I'm just going to use the 8 because I can do that. But if you can't, then you could just break it down. You can do 2 times 64 times 2 times 2 times 2. All right. But I'm not going to do that. What I'm going to do is 64 times 8, just like that. All right. Now, you could, if you want to do, you could do it 6 times 4 like this, 64 times 8 like that, or you could do 64 times 8, and you could use the distributive property of multiplication. And you could separate that 64 into 60 plus 4, plus 4 times 8, okay? And then you distribute. So you could do 8 times 60. Well, 8 times 6 is 48. And then you have that 0, so it would be 480. All right? And then you would afterwards do 8 times 4. Well, that equals 32. Oh, not 36, 32. And you're going to plus those together, and when you do, you're going to get 512, like so. Now, if you can't do it in your brain like that, rewrite it like this. 480 plus 32, 2, and that equals 11, 512. All right? That's what you do in a nutshell when it came to multiplying exponents with the same base, okay? Now, and that's the type of work you'd have to show if you were required to show work. Say you required on a test to show work, you'd need to show that type of work. You couldn't just do 2 to the power of 9 and then say it's 512 without showing your work, because if you did that, then you're likely going to be accused of using a calculator and cheating. So you need to show your work. If you were required to show your work, that's the type of work that you'd need to show. All right, so how would we times exponents with different bases? All right, well, let's take a look at that. So let's see here. All right, so let's say we had 2 to the power of 4 times 5 to the power of 3. Okay. Well, you can't do what we did before, where we had 2. If you remember correctly, it was 2 to the power of 3 plus 2 to the power of 2, and then we said that was 2 to the power of 5, because 3 plus 2 equals 5. You can't do that with this. You can't say that's equal to 10. You can't say that's 2 times 5 is 10 to the power of 7. That's not going to work. Okay, you can't do that. If you thought you could, you can't. All right. What you're going to have to do is you're going to have to solve for this, and then solve for that, and then times them together. So you're going to go 2 times 2 times 2 times 2 first, which equals 2 times 2 is 4, 8, 16. And then 5 times 5 times 5, well, that is going to equal 125. And then after that, you're going to have to do 16 times 125. All right? And to show your work, you need to write it out either this way, so you do 125 times 16, like so. And let's just do it that way. So this, all right, let's try it out. This times this is 30, so you put a 0 there, and then you put a 3 here. This times this, 6 times 2 is 12, plus 3 is 15, so you put a 5 there, and then you put another 1 there. 6 times 1 is 6, plus 1 is 7, 750. Then, to remember that this is really a 10, you add that 0 there to remember that this times this is 5, but it's really 10 times 5 is 50. Okay? And then you're going to do 1 times 2 is 2, and then 1 times 1 is 1. Okay. And then 5 plus 5 is, oh, because we're plussing them together, just in case you're confused what I'm doing here. After that, I'm going to plus them together. So 0 plus 0 is 0. 5 plus 5 is 10. Carry the 1. Now we have 7 plus 2 plus 1 is 10. Carry the 1 again. And that equals 2,000. Okay? You could have done it that way, but if you don't understand how to do it that way, you don't like it that way, you can do it a different way. Just real quick, by the way, why did I add that 0? I explained it to you, but if you don't get that, just remember, add a 0. So let's look at that again one more time. All right, I explained to you that it was the reason you added that 0 was because sometimes you forget that this is a 10 right here. See, that 1 is not just a 1, it's a 10, and then there's another 6 ones that make 16, all right? But, and then I said you add that 0 because it's really 10 times 5, which is 50. If you don't get that, just remember to just put a 0 there. 0 there, and then 1 times 5 is 5, 1 times 2 is 2, 1 times 1 is 1, and then add them all together, and you're going to get that 2,000. Okay? All right, another way you could have done it is you could have used the distribution property, and you could have expanded it. So you could have done something like this. You could have done 16 times 125, and you could have changed that up to 10 plus 6 times 120 plus 5, okay? And then you're just going to distribute, all right? You're going to do 10 times 120. So what is that? Well, 1 times 12 is 12, but then you got the 2 zeros. So it's going to be 1,200, okay? Let's use some different ink here real quick. Go to the toolbox. So 1,200, okay? And that was this one right here. And then after that, you're going to do 10 times 5. So that's going to be plus 50. Then you're going to do 6 times 120. Well, 6 times 12 is 72. So you're going to do 72 plus that 0. And then the final thing that you're going to, I should have drawn the line so you can see that. That's 6 times 12, okay? I mean 6 times 120. And then you're going to do 6 times 5, that equals 30. And when you plus them together, well, what is this? This plus this is going to equal 750. And this plus this is going to be 1,250. And remember, 750 plus 1,250, well, that's going to equal 2,000. Again, if you need to show your work because you're going to take a test, you don't have a calculator because you're not allowed one, then you need to show it something like this. You need to either do all of this, and that's showing your work, or you need to do something like this, which is also showing your work. But you can't just go, okay, well, this is 16. 16 times 125 equals 2,000. No, that's not showing your work. You have to, if you're going to show your work, and you're required to show your work, this is what you need to have, or this. Okay? All right, well, that's that for exponents.